So today we're going to analyze graphs of functions. So this is chapter 2, section 3. So yesterday we saw how to find the domain from an equation. Today we're going to be able to find the domain and range from a graph. Again, remember, domain are all the x values. When we're reading it off the graph, we're going to look at all the values from left to right. For the range, we're going to look at all the values from bottom to top. So we'll pretend like we're climbing along that y-axis. We're going to be giving our answers for the domain and the range in interval notation. Remember that if it's a solid dot or a solid line, it's going to be brackets. If it's open dots or open circles, then we would put parentheses. So next we're going to talk about when a graph is increasing, decreasing, and constant. So sort of think about if your piece of your graph looks like it has a positive slope, then that would be increasing. If it looks like it's got a negative slope to it and it's falling from left to right, then it's decreasing. If it's a flat line, if it's horizontal, then it's constant. And again, we're reading from left to right. We will write our answer in interval notation. Now, when we go to write our answers, you don't need to worry about transferring the brackets. You can write all of your answers for increasing, decreasing, and constant with parentheses. And that's what WebAssign is going to look for. Now, as we're going through the notes, if a graph doesn't have, say, a decreasing section or a constant, when you enter your answers on WebAssign, you're going to key it in as DNE, does not exist. All right, so now we're going to actually apply what we just read. So we're going to be finding the domain, the range, whether our graph is increasing, decreasing, or if it's constant. So let's take a look, and I'm going to zoom into number 1. Now, again, remember, domain are only x values. So what I can do is I can pretend like I'm walking along this x-axis, and I'm going to look to see what is my first x value that I hit as I'm walking along, and the first x value I hit is at -3. So I'm going to start here, domain, and it's an open circle, so it's going to be a parentheses. Then as I'm walking along, notice my next stopping point or my next x value is right here, the y-axis, which is at 0. So comma 0. So if you were to create ordered pairs along that line, you would see that there would be x values in all of them between -3 and 0. 0 is a closed circle, so it gets a bracket. Now, as I continue my walk here, notice that there's no graph in this section. So this is where I'm going to put a union, so then I can start it back up again, and my next x value is here at 2. Open circle. And then notice this arrow here. Looks like it's pointing up. However, notice this graph has like a curve to it. So really my graph is eventually covering more x's and going up. So it's actually going up and out. So this graph will eventually go to infinity. It'll slowly creep and keep going further and further to the right. So this is my domain. I've got this section of x values, and then I have from here to infinity. The range, we're going to pretend like we're climbing along the y-axis. I'm going to go from bottom to top. Let me get rid of all of this blue stuff. So now I'm not walking along the x-axis. Now I'm going to walk up the y-axis. So I go from bottom to top, and I'm going to look to see where I'm going to first hit a point, and it's right here. And this y value is 0. So range are y values. So it's an open circle, so it'll be a parentheses. And then I keep my travel And then my next stopping point here, my y value will be at +2. It's a closed circle, so it's a bracket. Then notice I've got a little gap here before I hit another y. So then I union that, and then I start again at +3, open circle, so it's a parentheses. And then as I continue my walk, notice the arrows pointing to infinity. And that's your range. I'm going to repeat that. So again, if I were to take a line and draw it on top, it doesn't have to go perfectly. I'm just trying to see the direction of which way it's either rising from left to right or falling. Both of these are rising, so they're both increasing. The increasing, decreasing, and constant answers come from the domain. So because I've already broken my domain apart, my increasing intervals are going to be from, for this graph right here, it's the 3, 0. And again, you don't have to put brackets. WebAssign's going to look for parentheses on all increasing, decreasing, and constant. And then this piece of the graph is this. So then I would also put that it is also increasing from 2 to infinity. You don't need to union it. You don't need to worry about brackets. Just put whatever piece of the domain is increasing. And both pieces were increasing. The decreasing, when you're entering this tonight in WebAssign, it's going to have boxes for each. So the decrease, you're going to type in DNE. Does not exist. There is no decreasing part of this graph. Same thing for the constant. There are no horizontal lines. So you type in DNE. Does not exist. Number 2. So again, I'm going to pretend like I'm walking along the x-axis and see what's the first thing I encounter. And the first thing I encounter is this arrow. Again, it looks like it's pointing down, but if you notice there's like a little arc to that graph. So eventually this is going to get further to the left and down. So this is actually approaching infinity along the x, and or negative infinity, and for the y. So I'm going to start from my domain. It's starting at negative infinity, and then as I walk along, my next x value is at -2. It's an open circle, so it's a parentheses. Then as I walk along, now I'm hitting a little gap here. And then my next x value starts up again here at +1. And then that segment ends at +2, open circle, so it's a parentheses. The range, we go bottom to top. Erase the blue. So again, as you're walking up or climbing up this y-axis, going up, first thing I encounter is this arrow. It's pointing down to negative infinity. Then as I keep going on my travels, it stops here at 0 with an open circle, so it's a parentheses. I've got a little space here, a little gap before it starts up again. And then it starts up again at +1 with a bracket because it's a closed circle. And then as I keep traveling, the last y value is at 2. Coincidentally enough, this one only has increasing parts, no decreasing or constant. However, number 3 will have all 3. So let me go ahead and erase so I can see where my graph is increasing. Again, don't look at the arrow because you might be thinking, oh, it looks like it's pointing down and it looks like it's decreasing. Again, draw a line on top of it. These are positive slopes. It looks like it's rising from left to right. So both of these are increasing. So for my increasing, again, all I'm going to do is recopy the domain. And it's going to increase on negative infinity to negative 2 and 1 comma 2. And again, WebAssign is going to expect just parentheses. For decreasing, you're going to type in DNE, does not exist. And for constant, you're going to type in DNE because there's no horizontal lines and there are no pieces of the graph that are falling from left to right. Now, number 3, we're actually going to encounter all 3. Let's go ahead and try this one. So again, as I'm walking across this x-axis, first thing I'm encountering is the arrow. Again, it looks like it's pointing up, but again, know that it's got this little curve to it, so it's going up and out. So domain is pointing to negative infinity. Then the next x value I encounter is right here at this open circle, and this is at negative 3.
Wait, why is that a negative infinity?
Because that's where it's, okay, for the y value, it's positive infinity, but for the x value, it's pointing to the left. So it's slanted, so it's actually going up and to the left, because it's got a little curve to it. Does that make sense?
Yeah.
Think of that arrow as like two directional, like it's going both up and left, because it's got that little arc to that graph piece. All right, next one. My next x value that I'm encountering is right here at negative 2. It's a closed circle, so it's a bracket. And then as I travel along, still got graph here, and then it stops here at 1. It's open, so it's a parentheses. Then I got a gap again, and then it starts up again at positive 3. And notice again, this looks like it's going up, but it's going up and out, so it's going to infinity to the right and infinity to the top. Now I do the range, bottom to top. So I'm walking up this way now. All right, so now let me erase all this blue. So the first y value that I encounter as I walk is right here at positive 1. Now, notice there's 3 different circles happening on this value, that's y value of 1. The closed circle overtakes the open circle. So I'm going to put a bracket around it because it does include 1 for that order pair. Now, it looks like there's a gap here, but if you use this piece of the graph, this one continues it. So this just goes straight to infinity. No gap here. All right, now we're going to look to see where our graph increases, decreases, and where it's constant. So again, don't look at the arrows because you might think that this little piece over here is increasing, but again, draw a line on it. It's actually falling from left to right. So this is the decreasing part. Here is my constant part, the horizontal line. And then here is the increasing part. So all you're going to do is go to your domain and pull out each piece. So this one was the decreasing, this one is the constant, and this one's going to be the increasing. Let me go ahead and write that in. So decreasing is going to be the negative infinity to negative 3, all parentheses. The constant is going to be the negative 2 to 1, and the increase is going to be the 3 to infinity. Oops, that's an 8. Number 4, we're still doing the same thing. Only difference is we're going to evaluate the function at the indicated value. Now, the other day when we had to evaluate the function, you had an equation and you had to plug in that number for x. What we're going to do here is figure out our y value for that x that's in the parentheses. So let's go ahead and evaluate all of these first, and then I'll go back and do domain range, increasing, decreasing, constant. So on this graph, remember the number that's in the parentheses is the x value. So what I'm doing is I'm looking at my graph, I'm looking to see where x equals 0, which is going to be, this is the x equals 0 right here, and then I come down here, and this is the order pair, 0, negative 4, so this answer is negative 4. Then for f of 3, I'm going to come over here to figure out where my x value is 3, which is right here. And it actually happens to be right on the intercept, or on the x-axis. So this answer is 0. These are actually my x and my y intercepts. All right, let's try the next one, and then I'll go back and do domain range, increasing, decreasing. So this one, they only want you to find f of 0. So again, I'm looking to see where x equals 0, which is right here. And this is hitting the y-axis at positive 1. And then for number 3, you're going to find negative 3. It's over here. And then you're going to find the y value, which is positive 1. And then here you're going to find where x equals 1, which is here. And its corresponding y value is 1, because it's the order pair 1, 1. Now we're going to go back, do domain and range, increasing, decreasing, and constant for all 3 of these graphs. Get rid of some of this. Okay, so let me come on over here now. All right, so let's do domain first. Now this is actually the graph of a parabola. And just remember, all x squared graphs, they're going to be all real numbers. So as we're walking across my graph here, wait, sorry. I got to go to number 4. Sorry. All right, so we're going to start here first. So domain, again, you're walking across. The first x value I encounter is at negative 2. And then as I keep walking, I still got x values, but it stops here at 0. And it was, let me see if I can erase this. This was a closed circle. So this will be a bracket. Then I've got the gap. And then it starts up again at positive 1 with the parentheses because it's open. And then again, remember this arrow means it's going up and to the right. So then it goes to infinity.
Shouldn't the negative 2 have a parenthesis instead of the
Yes, it should.
Because it's
Yes,
an open circle?
absolutely. Thank you. Yes, that is an open circle, so it's a parentheses. Good. All right, so that's the domain. Now let's do the range. Again, we're going to go from bottom to top. Let me get rid of the blue. So now we're going up. So the first y value I hit is at -4. It's closed, so it's a bracket. Now notice it looks like it might be a gap, but this one keeps going. And then if you come over here, this one takes over and it goes to infinity. So there are no gaps. So you'll look side to side to see if another piece takes over.
Well, wouldn't you count the one where y is -3, like where that open circle is, following the arrow?
All right, so I don't count this one because I don't want to stop it because this one kept going. And then I don't stop it here because if I come over here, this one took over. So you're going to have to look side to side because we're looking for y values and it never stopped. Once it started at -4, it kept on going and there were no gaps in y values. Let's try the increasing, decreasing, and constant. Again, don't look at the arrows. Sometimes they're misleading. Sort of just go over it. So this one looks like it's a negative slope. So this one's going to be the decreasing interval, which is this one. And then this one looks like it's rising from left to right. It's going to be my increasing interval, which will be here in the domain. So now I'll just rewrite that. So my decrease is going to be from -2 to 0. And my increasing interval goes from 1 to infinity. Again, it always comes from the domain. All right, now we're going to look at this parabola on number 5. Whenever your graph is a parabola, whether it's opening upward or downward, the domain is always going to be all real numbers. So again, if you were walking across the x-axis, the first thing I encounter is this arrow. And again, remember, it's pointing up and to the left. So this is the -infinity direction. And then as I keep walking, no gaps or anything, this one's pointing up to positive infinity and to the right to positive infinity. However, for the range, this one's not all real numbers. Again, you're going to come from bottom to top. So the first y value I encounter is +1 with a bracket. And then notice the arrows are pointing to infinity. So then it goes on. Now this time my increasing, decreasing, and constant isn't separated in the domain for me. So this is where I'd have to separate it myself. So this one's got an increase and a decreasing interval. So let me erase on there so I can show you where it is. The vertex is always the point where the graph changes direction. So again, don't look at the arrows because you may think they're both pointing up and they're both increasing. This piece of the graph is going to be the decreasing. It's falling from left to right, but this one's rising from left to right. So this one's the increase, this one's the decrease. Now notice in my domain, it's not separated for me. So this point right here of 0, 1, this is where it changes direction. So it's going to increase from 0 to infinity. Let me do red. 0 to infinity. and then it decreases from negative infinity to 0. So it's coming in here from negative infinity, and then it hits here after it falls, and then it starts up again from 0 to positive infinity. Again, for constant, you're going to type in DNE, does not exist. Let's try number 3. Oh, sorry, 6. So again, domain. We're walking across the x-axis. First thing we encounter is right here at -5. It's an open circle, so it's a parentheses. As I continue my walk, the next stopping point is the -3 with a bracket because it's closed. Now I have a little gap here before I get another x value, and then it picks it up at +1 with a parenthesis because it's an open circle. I'm sorry, -1. And then it continues on to +1 with a bracket. And then it's got a little gap. And then it starts up again at +3. And then again, this arrow isn't just pointing down, it's also pointing, it's really going down and out. So 3 to infinity. My range, bottom to top, so as I'm coming up this way, the first thing I encounter is this arrow. So it's actually pointing to negative infinity. And then over here, it goes to here, but then this one takes over, but then this one takes over, and then the final stopping point is +3. And it's an open circle, so it's a parentheses. So once you come to where you think it's stopping, look left and right to see if another piece of the graph is taking over. Now we're going to look for increasing, decreasing, constant. This one has an increasing interval, and it's also got a decrease. So don't look at this arrow over here. It does point in the right direction, but then again, don't get deceived here. So decreasing is going to be from here to here and from here to here. And then this one would be increasing because it's rising from left to right. So again, you can just go back to your domain. It's already broken apart for you. So my increase is this one, and then these two are my decreases. So the increase goes from -1 to +1. And again, I don't want a bracket there. I want all parentheses. And then the decrease is from -5 to -3 and from 3 to infinity. So again, remember when you're doing it in WebAssign, constant's going to be DNE. All right. Now we're going to talk about if a function is even or odd. So even functions, when I plug in a -x into the original function, if it simplifies back to the original function, it's even. So what will happen is you're going to plug in -x, but then the negative goes away and it goes back to the original. You will also say that even functions are symmetric to the y-axis. Odd functions are when you plug in a -x, that all of the signs on all of the terms become opposite of what the original ones. So each term is going to change the sign of the original. If it's an odd function, you're going to say that it's symmetric to the origin. Our graphs here will not have x-axis symmetry because if you think about it and you do your vertical line test, it would not be a function because it would touch that vertical line twice. In tonight's homework, you're going to have to do the vertical line test. Now, remember, for something to be a function, if you look at the equation, if y was squared or raised to an even exponent, or if y was an absolute value, it's not a function. So a function cannot have x-axis symmetry because it's going to fail that vertical line test. All right, let's go ahead and try these. So in order to determine if a function is odd, even, or neither, we're going to change the x to negative. So I'm going to be plugging in negative x for all of my x's here. So I'm going to take out x, replace it with negative x. Same thing here. And now I need to simplify this. If it simplifies back to my original, then I say it's even. If it simplifies to opposite signs of the original, then it's odd. If part of it's the same and part of it's different, it's neither. Okay? So this one I'm going to simplify, and negative x raised to an odd exponent to the third keeps it negative. So this becomes negative x to the third, and then this negative makes this x become positive. Notice if I compare it to my original was this. Notice all signs are opposite, so this makes this function odd because it's opposite of the original. So this was f of x, this one's f of negative x. So because these are opposites, then this is an odd function. And when it's an odd function, you're going to say that it's symmetric to the origin. So these go hand in hand. So if it's an odd function, when you graph it, it'll be symmetric around the origin. All right, another thing. I'm going to take out x and put in a negative x. So f of negative x equals negative x squared. Whenever a negative number is raised to an even exponent, it becomes positive. And notice when I plugged in negative x, it turned back into the original when I simplified. So this one is an even function. And it's going to be, it'll be symmetrical or symmetric to the y-axis. So when it's even, it'll be symmetric around the y-axis. If you think about it, this is a graph of a parabola. So if I have my y-axis here, it's going to look like this. And it'll be symmetrical. Think of this y-axis as the line of symmetry. Again, I'm replacing x with negative x. The 5 stays the same. The only thing I'm changing is the x in this equation. I'm going to simplify this, and it turns into negative 3 times negative x becomes positive 3x. So because the 5 stayed the same, but the 3 it changed to the opposite sign, everything needs to either stay the same or everything needs to go opposite sign. So this one would be neither, and it has no symmetry. We're going to do the same thing. We're going to determine if it has even, odd, neither, and determine if it has symmetry. Now, I know the previous slide only asked for even, odd, or neither, but I wanted to put that in there just to make sure that the other classes I had only did those examples. So let me do this one with you guys. So again, I'm going to change all of my x's to negative x. So it becomes negative x raised to the fourth minus negative x squared minus 1. Now, we need to follow order of operations. So again, whenever a negative number or a negative variable is raised to an even exponent, it turns positive. Don't try to do that keep, flip, change with that middle yet. So we need to do the exponent first. So this becomes positive x to the fourth. This becomes positive x squared. Notice I rewrote the negative sign and then the minus 1. Notice after I did that, it turned back into my original. So this is an even function and it has y-axis symmetry. So it's symmetrical to the y-axis. Then the last one on this part of the notes, again, replace x with negative x. So 2 times negative x cubed plus 3 times negative x. Again, a negative number or a negative variable raised to an odd exponent makes this become negative. And then positive 3 times negative x becomes negative 3x. Notice both signs went opposite, so this one is odd, and it's symmetrical to the origin. All right, so again, whenever your question says to find the zeros, or to find the roots, or to find the solutions, all of them mean exactly the same thing. I am going to set my function equal to 0 and find the value of x. So I'm going to take out f of x, put in 0, and we already did this the other day in the homework, because what they said to do is make f of x equal 0. This is what we're doing. So this is a trinomial. I need to factor this small enough where I can guess and test. The factors of 2x squared are going to be 2x times 1x, and the factors of 1 are 1 times 1. In order to get a positive 1, signs need to be the same, and the sign that they're both going to have is that middle sign, which is negative. If you do a quick FOIL on this, it does go back. So now all I have to do is set each one equal to 0, add the 1, 2x equals 1, divide by 2, x equals 1/2. Over here, add 1, x equals 1. Remember, these are zeros, they're x-intercepts. So 1/2, comma 0, and 1, comma 0. And this is what it means to find the zeros. You're finding the x-intercepts. Again, this is a graph of a parabola. Let's do one more example. Got 1 minute. Again, set it equal to 0. 2x plus 5 over x plus 5. I'm going to get rid of the denominator by multiplying both sides by it. And then I'm left with 2x plus 5 equals 0. Subtract the 5. 2x equals negative 5. Divide by 2. X equals negative 5 over 2. As a coordinate, negative 5 over 2, comma 0. Well, have a, bye, you're welcome. I'm sorry?
You already posted it.
Not yet. Well, the Canvas assignment's posted, but it's not on WebAssign yet. So you will have a WebAssign posted before 2:30. I'll try to work on it now. Have a wonderful day. Bye. Yes.